Okay, hi everyone. This took longer than I expected, but it's finally time to continue looking at Dr. Lyre's little talk. But before we begin, I'd like to give a shout out to a member of the older generation of YouTube skeptics. Now back from a long hiatus, the living dinosaur. He used to pwn creationists back in the day before the skeptic community, just collapsed into a mess of people arguing about identity politics. He's hilarious, and he's back now. I'm linking to his channel in the description. I really recommend that you give him a look. Another thing I'd like to address is Dr. Lisle's degree. I know I said he has a PhD in astrophysics, but in his talk, he said astronomy.
Well, it's good to be with you this evening, and I get to speak on my specialty topic of astronomy. That's what I got my doctorate in, and it's what I...
This was pointed out in the comments, so let me set the record straight. According to every source I can find, including Lisle's own website, the Institute for Creation Research, his current employer, and his former employer Answers in Genesis, Lisle has a PhD in astrophysics. I think the reason why he said astronomy instead of astrophysics is that he's addressing creationists, and come on, do you expect creationists to be able to handle two four-syllable words, both starting with astro?
And so I want to now talk about a couple of issues where the secular experts today have not quite caught up to the truth of the Bible. One of those deals with the age of the universe.
Okay, now let's see what brand new, brilliant insights an actual astrophysicist can bring to this discussion.
Jupiter gives off twice as much energy as it receives from the sun. Okay, it's actually, it gets some energy from the sun, but it gives away twice as much. Okay, and you can't keep doing that forever, right? Because it's losing energy.
Really? You're going to use the same crap arguments as Kent Hovind? Why don't you talk a little bit about how fast Jupiter is cooling off using terms that a layperson might understand? Why don't you mention how much its temperature drops every year? You're not gonna say that? You're not gonna do the math for us? Well, I guess I'll just have to work it out for myself then. Jupiter consists almost entirely of hydrogen, 75% by mass, so for our current purposes we can treat the planet as consisting entirely of this material. Yes, this is an approximation, but we will still be able to get a good idea of the order of magnitude of the yearly average temperature loss. If Jupiter gives off twice the energy it receives from the Sun in the same amount of time, that means the net loss is equal to what it receives, which is not hard to calculate since we know what power the Sun puts out, the radius of Jupiter's orbit, and the radius of Jupiter itself. This, multiplied by the number of seconds in a year and divided by the specific heat of hydrogen gas multiplied by Jupiter's mass, gives us the yearly decrease in the planet's average temperature, just shy of 1/1,000,000th of a degree. And this is perfectly consistent with the planet being billions of years old, yet still radiating primordial heat left over from its formation, which is exactly what any freshman astronomy textbook will tell you. As an astrophysicist, you are definitely familiar with the high school physics I just showed you, so you, sir, are lying.
The problem's even worse for Neptune, which gives off 2.7 times as much heat as it receives from the sun.
Ah, yes, and we don't know enough about the interior of Neptune to be able to say whether it is just primordial heat, so we don't know, and I guess that means God did it, huh? The good old God of the Gaps argument.
The Earth's magnetic field. The Earth has a magnetic field that's caused by electrical current in the core, and it's been decaying in a steady exponential decay. Now we think during the flood year, because of all the tectonic activity, that would have disrupted those currents, and you'd have rapid oscillations in the field strength. But the total energy is just going to drop.
Really? So again, you resort to using arguments that you know were refuted long ago, and that would never fool anyone with even a high school understanding of physics. Magnetic minerals freeze into place in the direction of the geomagnetic field when rocks are formed, such as when lava from volcanoes cools down. Different strips of rock show that the direction of the magnetic field has changed over time. Lisle can't deny this, which is why he accepts that the magnetic field has fluctuated in the past. He gets two things wrong though: the overall exponential decay rate and the time frame. The exponential decay rate is simply made up. This data point is not an empirical observation, but a calculation by creationist physicist Russell Humphreys, based on the assumption that 6,000 years ago the Earth was made entirely of water, in which a quarter, because reasons, of the hydrogen atoms were magically aligned by a wizard who then transmuted the water into other materials. Again, using magic. In other words, Humphreys assumed his desired conclusion and invented a method, which, I repeat, involves magic, that would allow him to reach it. This is as far from science as it gets. I'm not sure I expressed myself clearly enough. Humphreys relied on circular reasoning, which in turn relied on appeals to magic, in what was supposed to be a scientific paper. Now, you don't really think it was published in a peer-reviewed journal, do you? No, of course not. It was published in a creationist journal, and I'm linking to it below. You should actually read it because it's funny. As for the time frame, radiometric dating disproves the idea that the fluctuations took place during the year of the flood, even if we grant the ridiculous idea that the flood actually happened. The deposits we know of give us a continuous record spanning the past 160 million years, give or take. Now, of course, creationists will say that radiometric dating doesn't work because it assumes that the decay rates are constant. So let's address that one. Unlike the assumption that the Bible is inerrant, this is actually a conclusion based on evidence. For as long as we've measured radioactive decay rates, they haven't changed. Also, decay rates depend on the configurations of isotopes. To suggest that the same configuration once resulted in a different half-life would be to suggest that fundamental constants have changed. This would also affect everything else that depends on those constants, and we see no indication of this anywhere. But let's ignore that and see what happens just for fun. If all the magnetic strips formed in 1 year, that means we would have to compress 160 million years worth of radioactive decay into 1 year, to say nothing about the remaining 4.3 billion years of the Earth's history the creationists have to explain away, or the still remaining 9.4 billion years of the age of the universe. But let's ignore that and only look at the 160 million years of decay happening in 1 year. Let's ignore the increase in ionizing radiation. We'd also get 160 million times the normal radiogenic heat, that is, the energy from all the nuclear processes. A low estimate of 15 terawatts of radiogenic heat escapes the Earth's surface normally. 30 terawatts is more realistic, but let's be nice to the idiots. That times 160 million divided by the Earth's surface area and the Stefan Boltzmann constant, take the fourth root and we find a surface temperature of about 3000 Kelvin, which is enough to melt the crust. Remember that this is from just the radiogenic heat. We haven't taken sunlight into account. If we add that, the surface temperature would be almost 3300 Kelvin, which is past the boiling point of iron, just to give some idea of how hot this is. Of course, the fact that the entire crust would melt also means that the magnetic strips could not have formed at different points in time. They would all form at the same time after the decay rates returned to normal and the crust cooled down. We exist. The magnetic strips exist. That means the laws of physics didn't magically change to allow your fairy tale to be true. Look, the flood didn't happen. You know this, Lisle. You know that radiometric dating works. You know that the exponential decay rate of the Earth's magnetic field is fiction. You know all this. You, sir, are lying.
It's not just Earth, but a lot of the other planets of the solar system also have these magnetic fields. Jupiter's would be bigger than the sun if you could see it. It's a very powerful magnetic field. And why is it still so strong if the planet's billions of years old? And I'm going to suggest it's because the planet's not billions of years old. It's thousands of years old. So it hasn't had time to decay yet.
But, Lisle, there's a problem here. You're assuming that Jupiter's magnetic field is decaying. And it's not.
The planet Uranus. Uranus is tilted on its side as it orbits the sun, so it rolls around the sun, one way to think about it. And the magnetic field axis is stuck in the side like a bar magnet. It's not even lined up with the rotation axis, so the magnetic field would wobble as the planet rotates. Really strange. So the planet Uranus is just really messed up on a number of levels. And I think God did that just out of his creative diversity.
You're thinking, but I can explain all of that. I know you can explain all. So can I. It's not hard to come up with ex post facto justifications for why God would have done it that way. Why is it not hard? Because theism is not well defined. That's what computer scientists call a bug, not a feature.
And in fact, the Voyager 2 spacecraft, when it flew past the planets Uranus and Neptune, it measured their magnetic field and confirmed that it's consistent with thousands of years of decay. Isn't that interesting? My colleague, Dr. Russ Humphreys, who used to work for us at ICR, he's retired now, but he actually predicted the magnetic fields of Uranus and Neptune before they were measured by the Voyager 2 spacecraft.
Essentially, what he did was assume that because these planets are bigger than Earth and smaller than Saturn, they should have magnetic dipole moments with orders of magnitude between Earth and Saturn. This is not a hard guess, and considering that he only ever predicted the order of magnitude, this is not impressive at all.
The moon is actually moving away from the Earth. It's actually, and the reason it does that, the moon induces tidal bulges on the Earth. It pulls on the Earth's oceans, and that causes these tidal bulges. The tidal bulges get ahead of the moon because the Earth rotates faster than the moon orbits, and so the tidal bulges are always a little bit ahead of the moon, and they pull forward on it. And the counterintuitive thing is when you pull forward on something in orbit, it moves out. When the astronauts want to go into a higher orbit, they thrust forward, and that moves them out. It's a little bit strange, but if you've ever played with a gyroscope, you know that when things are spinning, they don't always act the way that your intuition would expect.
Well, that was actually a really good explanation. Now, go ahead and ruin it.
But the moon is moving away at about 1.5 inches a year, so it's not a huge rate. If you run it backwards, that means 6,000 years ago, it would have been something like 730 feet closer to Earth. Not a big deal, considering the moon is 248,000 miles away. What's 730 feet among friends, right? But if you run it back billions of years, you got a problem. And you have to do the math right on this, by the way, because if you're running the movie backwards, as the moon gets closer, the tidal bulges get bigger, and it gets closer, and they get bigger, and it gets faster, you see. And it dives in at 1.4 to 1.5 billion years.
That's assuming there's no variation in how the energy of the tides dissipates, which there is. It depends on how the continents are configured. And during most of Earth's history, they've been clumped together. This means that the recession rate would have been slower in the past. Lisle also neglected to mention that the recession rate is related to the Earth's rotation rate. The Earth's rotation slows down as the moon recedes. We know from corals that produce both daily and yearly patterns as they grow, as well as tidal rhythmites, that's when tides deposit sediment on a daily basis, how many days there were in a year at different points in the past. Indeed, days were shorter in the past, but by an amount consistent with the recession rate having been slower in the past. You know this, Lisle. You, sir, are lying.
Comets are made up of icy material, and they orbit the sun in elliptical paths. They tend to go very far away from the sun, and then they come close and they whiplash back out. And when they're far away from the sun, their icy material remains icy material. When they come close to the sun, ice close to the sun, that can't be good. Every time you see a comet, it's getting smaller. It's losing mass. And it can't do that forever because it has no source of new mass. So it just gets evaporated away. And we estimate that a typical comet can last no longer than 100,000 years maximum. So why do we still have comets?
Lisle, could you come up with something new soon? Perhaps something that you don't already know is complete horseshit? The short period comets we see today are not the same as the ones the dinosaurs would have seen. Those are long gone. Comets are replenished.
The idea is there's this vast reservoir of potential comets out there orbiting way beyond where we can detect them. And every now and then one of them is thrown into the inner solar system, becomes a brand new comet. Pretty clever. There's no evidence of an Oort cloud, though. The only place you'll find it is in textbooks, but you won't find it in the actual universe.
We can't see objects in the Oort cloud because they're too small, too dim, and too far away. But we actually know of comets, for example Comet West, whose orbits take them far enough from the Sun to actually have apelia in the Oort cloud, tens of thousands of AU from the Sun, even though their orbits are eccentric enough to pass through the inner solar system. We also know of hundreds of objects in the Kuiper belt and the scattered disk, including dwarf planets with highly eccentric orbits like Sedna. We know that objects in these regions could have their orbits perturbed by Neptune, and this, rather than the Oort cloud, is probably the origin of most short-period comets. For this argument to carry any weight, objects we can observe directly could not exist. You know that while we cannot see the Oort cloud directly, what we can see is perfectly consistent with the hypothesis. You, sir, are lying.
Spiral galaxies. Now, not all galaxies are spirals. Some have more of an elliptical shape, but a lot of them are spiral. And these spiral arms rotate differentially, which means the inner portions rotate fast, as indicated by the arrows. The outer portions rotate slower. And so what you would think then is the galaxy would have to be twisting itself up. It's winding itself up tighter and tighter. That spiral structure would have to get tighter every rotation. And it turns out in 6,000 years, it hasn't rotated even once, and so it's not a problem. You can, in fact, in these barred spiral galaxies, you can still have that bar structure there. It's just starting to wrap up a little bit in the middle there. In 6,000 years, not a problem. But if these galaxies are billions of years old, it'd be a huge problem because they'd be twisted beyond recognition.
Oh, for crying out loud. The differential rotation refers to the stars, not the spiral arms. The spiral arms are density waves that actually move slower than the stars. It's like a traffic jam. Cars come in and cars go out, but the jam pretty much remains in place.
And so my secular colleagues have to figure out ways to make new spiral arms as the old ones are wrapped up beyond recognition, spiral density waves and whatnot. But it's just easier to believe that the galaxies are the age the Bible indicates.
It's easier to believe.
You might notice, too, that these spiral arms have kind of a bluish tinge to them. That's because they have a higher proportion of blue stars relative to the central bulge. And blue stars themselves are an evidence of the youth of the universe because blue stars cannot last very long. And my secular colleagues have to believe that, well, they obviously have formed there recently. But no one's ever seen a star form.
As you damn well know, Lisle, that's because star formation isn't like flipping a switch. We are never going to see the entire process of a molecular cloud collapsing and forming a star, because that process takes longer than you at least pretend to think the universe has existed.
And I think there are some very serious physics problems getting a star to form from a nebula. The idea is these nebulas collapse in on themselves, but gas normally doesn't collapse in on itself. Gas normally fills the container, right?
You have got to be kidding me.
Gravity, you fucking retard! Gravity! Have you ever heard of fucking gravity? Gravity!
Gas tends to do that. Gas pressure tends to be a lot more substantial in space than gravity. Now, once you make a star, its own gravity will keep it there because the gravity overcomes the gas pressure. But getting it to that state is a challenge, and it may even be impossible.
Oh, well, sorry, I got ahead of myself. But apparently you acknowledge that if there's a high density region in a gas cloud, then the cloud will collapse. Now, what could cause a high density region to form? Maybe the cloud isn't an isolated system. Maybe it interacts with other objects. Maybe it can collide with another cloud. Maybe it can be affected by tidal forces from gravitational interaction. Maybe it can be affected by, objects moving through it. Maybe it can be affected by the shock wave from a nearby explosion. Maybe gas clouds are affected by the laws of physics. Ever considered that? Yeah, you have, at some point during your education. As always, you, sir, are lying.